In this video, we're going to talk about particle traveling along a line. We have a particle moving along the x-axis, which means that particle will move horizontally. If the velocity is positive, particle will move to the right. If the velocity is negative, particle will move to the left. If the particle was moving along the y-axis, that means it will move vertically. If the velocity is positive, particle will go up. If the velocity is negative, particle will go down. But since this is moving along the x-axis, we're talking about the horizontal movement. And here's a position function. Notice the domain is greater than or equal to 0 because time cannot be negative. It says find the velocity and acceleration and describe the motion of the particle. So in order to find the velocity, we need to find the derivative of position, which is 6t squared minus 28t plus 22. Let's factor out the 2. So you get 3t squared minus 14t plus 11. And this is factorable. So you get v of t, velocity is 2 times 3t, and t, you get minus 1 and minus 11 over here. So when is the velocity equal to 0? Velocity is equal to 0 when 3t minus 11 is 0 and t minus 1 is 0. Therefore, t is 11 over 3 and t is 1. So when t is 11 over 3 and t is 1, that's when the velocity will be 0. So let's come up with the velocity chart. Now, remember the domain it starts from 0. And then velocity is 0 at 11 over 3. Sorry, it should be 1 and 11 over 3. So let's plug in some numbers and see what kind of sign we get. Plug in 0.5. You get positive. Because negative times negative is positive. What's a nice number to plug in here? 2. Plug in 2, you get negative. And choose like number 10. Plug in 10, you'll get positive. So based on this chart, you know that the particle moves to the right on the interval from 0 to 1. And 11 over 3 to infinity. And particle goes to left on the interval from 1 to 11 over 3. And what happens at 1 and 11 over 3? The particle is at rest because the velocity is 0. Now let's graph the position and the velocity and see what happens. So here's a graph of position and velocity. Position is represented by the blue graph and velocity by red. Let's get a better view. So I'm going to change the window setting. I'm going to start from 0 for x min. And for y min, I want to go down to negative 30. And let's graph it and see what happens. So here's a graph. And notice the velocity is 0 at t equals 1 and t equals 11 over 3. So what happens from 0 to 1? Velocity is above the x-axis, which means velocity is positive. Since the velocity is positive, position is increasing on that interval. What about from 1 to 11 over 3? Velocity is negative because velocity is below the x-axis. Therefore, the position is decreasing on the interval. What happens after 11 over 3? Well, the velocity is positive. Therefore, the position graph is increasing. Now let's find the acceleration. In order to find the acceleration, that is the derivative of the velocity or second derivative of position. So the acceleration will be 12t minus 28. And let's factor out the 4. You get 3t minus 7. So when is acceleration equal to 0? That's when 3t minus 7 is equal to 0, which is t equals 7 over 3. That's when acceleration is 0. So let's get the acceleration chart. And you know there is 0 at 7 over 3. And it starts from 0. Let's plug in 1. What happens when you plug in 1? You get negative. And after 7 over 3, you get positive. So it looks like the particle is decelerating from 0 to 7 over 3. And then after 7 over 3 is accelerating. From 7 over 3 to infinity. And let's look at the graph. Compare the graph of velocity and acceleration and position with acceleration. Now, y my 3 is 12x minus 28, which is the acceleration. So let's graph it. That is the second derivative or acceleration graph. I just want to compare the velocity and acceleration. So what I'm going to do is I'm going to deselect. Press enter. So now this means that I'm only seeing the graph of y2 and y3. So now remember, this acceleration is the derivative of the velocity. And the acceleration is 0 at 7 over 3. Notice acceleration is negative from 0 to 7 over 3. That's why the velocity is decreasing. And after 7 over 3, acceleration is positive. Therefore, the velocity is increasing. Now, let's compare the position and the acceleration. So now I want to select that. So use the arrow, click enter. And now I want to deselect. So just press enter. Now I'm only graphing y1 and y3. So notice, until t equals 7 over 3, second derivative is negative. That means the position is concave down. And what happens after 7 over 3? Well, the acceleration is positive, which means the second derivative is positive. Therefore, the position is concave up. I hope you see the relationship between these three graphs.